Alright guys, what I want to do is help you out with a little tutorial on the handouts that you're going to be working on for the next couple of days. Ultimately, you are responsible for the learning here, but I think that you could use a little push in the right direction. What's most important is that you try to apply what you've learned in class to an actual application. And yeah, it's going to hurt a little bit, and you got to think. And you can't get frustrated just because you don't know the answer immediately. Let's try and work through this. What I see here is a connection between weights and cost. And the cost is a constant, so there's no slope. So these are horizontal lines. So what I want to do is just maybe work through, say, the dog that weighs over 15 pounds but under 50. And think about how I'm going to discuss this. First of all, say I had a dog that weighed 35 pounds. How much does it cost to get that dog groomed? Well, I look here, and over 15 and under 50, it costs $50. So that would be a coordinate pair of 35, 50, where 35 was the weight and 50 was the cost. So I find 35 over here on my graph, and I find 50 on my y-axis, right? And I plot that point, which is right there. If I look at the lightest dog in that category, it's just over 15. So here's the over 15, and I'm going to go up to the top. 15 is not included, so I'm going to put an open circle, and this is going to go over 15 all the way to under 50. So when I get to 50, I'm here, and under 50 is an open circle, and I'm going to connect it. That's the picture. What's the function look like? The function looks like f of x is equal to 50, because there is no slope. It's a horizontal line. And the domain is all the way from over 15, so it's over 15 to under 50. And I put a parenthesis like that. So that's 1/3 of this problem. Now you need to finish it up by dealing with the 15 and under and the over 50 and finish the graph as well. So you should have two more functions with the domains for them, and then you should have two more lines, and one of the lines is going to be up here and one of the lines is going to be down there. This one will be for the heavier weights. Sorry about that, but this one right here will be for the heavier weights, and this one right here will be for the lighter weights. This next problem is a little bit more mechanical. It's not a word problem application, but the showstopper here apparently is this notation right here. And we've talked about this. That's just a fancy way of saying, right, x is less than 5, strictly less than, so parenthesis, greater than or equal to 0, okay, included. So from 0 to 5, those are the values of the x values that will go into this function. So when I go to graph that, I just go up 3, and I'm going to make a solid dot because that's at an x value of 0, and that means that it's included, so I'm going to use the solid dot. Now I'm going to go all the way to 5. When I put 5 into this function, the opposite of 5 plus 3 is -2. So at 5, I'm at -2. That's not included, that's open, and I connect it. You could have also said, yeah, I could plot 3 and go down 1 over 1, down 1 over 1, down 1 over 1 until I get down here. That's another way. But I think that's a showstopper on this second function, because you got this f of x is equal to 2x minus 12. So instead of using f of x, what I'm going to do is put in the two values that I want to use. I'm going to use the leftmost value, which is 5. So I'm going to put 5 in for x and evaluate it. Then I'm also going to evaluate the function for the value of 8, because 8 is the under end of this segment. So f of 5 is equal to 10 minus 12, which is negative 2, and f of 8 is 16 minus 12, which is 4. So that's 5, negative 2, and 8, 4. Those are my coordinates. So I go to 5, negative 2, and at 5, for the second piece, right, if I look at the evaluation of the second function here, right, and I'm talking about this, I'm going to go from 5 included all the way to 8 not included. So 5 now is going to be a solid circle, so now it's included, and when I go up to 8, 4, I'm going to be an open circle. I'm going to connect that. All right, so now I need to just sort of move, whoops, I guess that's not going to work. I need to, hang on a second. So now what I need to do is evaluate my domain, right? So the furthest left this picture goes is x of 0, and the furthest right is an x of 8. So my domain goes from 0 to 8. 8 has the open value, 0 has a closed value, or if I want to write it as the original expression up here, that's less than 8 and greater than or equal to 0. That's it. Thinking about everything we've learned and everything we've talked about. You got to go outside the box on this. At some point, we're going to ask you to think about things on another level. That's the goal. Hopefully this was helpful.